All right, let's check and see how you did on problems 6 through 10 of this assignment on sampling distributions. So I went in depth on 1 through 5, but I'm not going to do so much on this one. Here, the bank believes 0.07%, 7% of people are faulty. Make sure you did 0.07, not 0.7 out of 200. So they think that all their samples should be centered around 0.07. And here's what the variability of those samples would be. But they get a sample that had 0.10. I guarantee you banks are doing this all day, every day, because is COVID really changing the default rate on loans right now? So they take a sample and they see, do we have over 10% that are not making timely payments? So they see, okay, how far away is this 10% than what we expect, what it has normally been in the past? And that's 1.67. So that's actually a good sign. That's not unusual. So 10% is not something to fret about right now. Okay. But it does say, does this ask for proportion? Yeah. What's the probability that you get a sample with over 10% of clients not making timely payments? And that's 4.75%. All right. Next, number 7. We have a random selection of 100 students. In the past, we know that about 30% of university students wear contacts, but maybe they got a sample that had 1/3 in it. So this 1/3 is 1 over 3, which is 0.33. So that's what we're checking to compare to the previous amount and claim. So then FYI, here was your standard deviation. Remember, we're always putting that 0.3 in there, P, not P hat. So how far away was 0.33 from the claim? Well, it was only 0.65. Do not think that is 65%. That is not what the probability is. That 0.65 says you're just a little bit, like if this is one standard deviation, you're about almost 2/3 of a standard deviation above the mean. And so that's where our line is drawn, and then the probability is this area here. So we norm CDF. That's a Z-score. 299, that's 25.78%. Okay, next. Oh, I love this problem. This is so good. Is this farmer going to get to load off his defective truckload of apples? Well, guess what? Suppose that in fact 8% of the apples on the truck are defective and do not meet the desired standard. So that is the population amount, okay? Because that is reality. So reality, what is actually happening is that. Now, the breaking point is, so the factory will accept, so here's 8%. So if 8% is the center, so the population is the truck of apples, then all those samples you get off the truck should be centered around 8%. Okay? And if all those samples are centered around 8%, then the question is, how many samples are down here where the farmer is like, whew, I got to pull a fast one over on the factory because they took my apples, even though I have defective apples. They took my apples thinking I have 5% or less defective. Okay, so this is the proportion of samples that are not defective, and that's the probability that they'll get one of these samples, and then he's going to get to offload his apples, even though his truckload has too much defective apples on it. All right. So then that's what we're doing. How far away is this 0.05 from the 0.08? And that's only 1.36. So about 8.69% of the samples will let the farmer pull a fast one and get rid of his truck. Okay. Next, number 9. We have that sample of 200. Suppose the proportion of all students what is this question about, who have received a student loan in the past 6 months is 40%. Okay. But what's the probability that the proportion of students who have received a student loan is less than 32%? Okay. So that's our sample results. So we're just going to do that, see how far away that 0.32 is from the expected of 0.40. And that actually is a lower outlier. So if you got that number of 0.32, you might suspect this population amount might not truly be centered there. All right, but look, just a really small percent. The probability that it is 32% or lower is only 1.1%. Okay, now there's a lot of numbers in here and a lot of words. So my students are like, what's what? So what happens is, this is the population. This is not going to go into our information. Okay, and neither is this one. Okay, those two numbers are how this population amount came about. So this is the proportion of the Penn State bachelor's degree programs that have military experience. Okay. So that is then the population amount. So all the samples should be centered there. So look, we randomly select 75. So that is your sample size of 75. And then the results they got from their sample, what's the probability that more than, so the upper part of above 25%. So see, they want to know what's the probability you get that sample or higher. So that's my p hat minus, or compare my p hat to the population rate. And then there we want to go more than that when we norm CDF to get that probability. All right, and then now our last two. So on these problems, then let's look at what's happening here. So assuming that 80% of all 8th graders can pass the physical fitness test of all 3rd graders, so then that's our population amount. So that means all the samples we should get should be centered around 80% passing the physical fitness test. Okay? All the samples we get should be centered around 80% passing. 80% passing, 80% passing. A little less, a little more, but they're centered around 80%. Well, they get a sample. So here's their sample results. A random sample of 20. So N is 20. And they had 13 who passed. So guess what? 7 who failed is extra information and not needed. So my P hat, so the sample results of our 3rd graders was 13 out of 20, which is 0.65. So let's see how that compares. Is this 0.65 concerning? Is it far away from 0.80, making me think, whoa, we really do not have our data centered around 0.80? Well, let's see. 0.65 minus the 0.80 up. It's only 1.69 standard deviations down. So that is not alarming. That could be just because of sampling variability. I am not worried. I do not have evidence that the 3rd graders that would pass this physical fitness test is lower in this area. Okay. So what's the probability that you get that? So we're going to do less than that z-score, 4.55%. All right, here we go. Last one. The frequency of color blindness in Caucasian Americans is 0.08, not 0.8. Pay attention to your decimals. Okay. We have a random sample of 125, so that's our N. And 16, oh wait. Ooh, ha ha ha. Between 6 and 16 individuals were colorblind. So what's the probability that between those? Guess what that means? You have 2 P hats. A 6 out of 125 is a P hat, and 16 out of 125 is a P hat. And we want to know the section. So let's see, where are these centered at? 0.08. 6 out of 16 is down here, and 16 is up here. 16 out of 125. So the question is, what's this area in the middle? So you have to get a z-score for both of these sections, and then norm CDF between those two z-scores. So that's what we got, negative 1.45 to 2.27, and then we norm CDF. So 91.49% of samples would have between 6 and 16 colorblind Caucasian, what is this? Caucasian Americans, males, Caucasian males. Okay, so there you go. That is your sampling distribution with proportions. And so now you're going to warm this up so that you can take the quiz on this. Then after that, we're going to go into sampling distributions with means. A couple little added things with that, but similar ideas. That's why it's really important to understand what you had going on here. So good luck on your warm up and your quiz.